A new type of nuclear reactor designed to power crewed outposts on the moon and Mars could be ready for its first in-space trial just a few years from now, project team members said. Our flight test is the next big step for the Killer Power experimental fission reactor, which aced a series of critical ground tests from November 2017 through March 2018. No off-Earth demonstration is on the books yet, but Killer Power should be ready to go by 2022 or so if need be, said Patrick McClue, Killer Power project lead at the Department of Energy's Los Alamos National Laboratory in New Mexico. I think we could do this in 3 years and be ready for flight, McClue said late last month during a presentation with NASA's Future in Space Operations Working Group. I think 3 years is a very doable time frame, he added, stressing that this is his opinion, not necessarily that of NASA, which is developing the Killer Power project along with the DOE. Nuclear energy has been powering spacecraft for decades. NASA's Voyager 1 and Voyager 2 probes, New Horizons spacecraft, and Curiosity Mars rover, along with many other robotic explorers, employ radioisotope thermoelectric generators, RTGs, which convert the heat thrown off by the radioactive decay of plutonium-238 into electricity. The power output from RTGs is relatively low. The one used by Curiosity and NASA's upcoming Mars 2020 rover, for example, generates about 110 watts of electricity at the start of a mission. This output declines slowly over time. A crewed Mars outpost will have considerably higher energy demands than that, around 40 kilowatts of continuously available electrical power, 40 kW, even for the small research station NASA envisioned setting up by the late 2030s, McClue said. After all, the pioneers will need electricity to purify their water, generate oxygen from the carbon dioxide-dominated Martian atmosphere, charge up their rovers, heat their habitats and so on. Human exploration of Mars will therefore demand a different energy production strategy, and that's where Killer Power comes in. Like nuclear power plants designed to stay put on Earth, Killer Power is a fission reactor. It converts the heat generated by splitting atoms into electricity via devices called Stirling engines. Nuclear power plants, by contrast, generally use this heat to create turbine-turning steam in the ground. Test series that wrapped up in March 2018, which was known as Krusty, Killer Power reactor using Stirling technology. The reactor converted 30% of fission heat into electricity, McClue said. This efficiency dwarfs that of RTGs, which convert about 7% of available heat. This was an extremely successful test, McClue said. The Killer Power project officially started in 2015, but its architects proved out the basic concept back in 2012 via an experiment called demonstration using flat-top fissions, DUF. And yes, Simpsons buffs, the Killer Power folks are your people. Duff and Krusty are references to the iconic animated TV show. Project team member Dave Poston is a big fan, McClue said. For the uninitiated, Duff is the beer favored by Homer Simpson, and degenerate, tax-dodging loud Krusty the Clown hosts a kids TV show in the Simpsons universe. As its name suggests, the Killer Power reactor is designed to generate at least 1 kilowatt of electrical power, 1 kW. Its output is scalable up to about 10 kW. And it can operate for about 15 years, McClue said. So, 4 scaled-up Killer Power reactors could meet the energy needs of NASA explorers, with a 5th reactor likely landed to provide a spare. These devices are smaller than you might think. The entire 10 kW machine would stand just 11 feet, 3.4 meters, tall, and the reactor component would be the size of an old-school metal garbage can. The reactor core alone, without any shielding, would be about as big as a roll of paper towels, McClue said. Still, these pieces are heavy. With shielding, the entire 10 kW reactor would likely weigh about 4,400 pounds, 2,000 kilograms. Some of this mass could be pared down if the reactor is buried and therefore doesn't require as much astronaut protecting shielding, McClue said. Without shielding, the 10 kW reactor would weigh about 3,300 pounds, or 1,500 kilograms. The Killer Power reactors will be quite safe, he stressed. The devices won't be turned on until they reach deep space, so there will be no threat of dangerous radiation exposure even if the reactor's rockets crash back to Earth. Flipping the switch won't necessarily always occur on the surface of the moon or Mars. By the way, the killer power reactor is flexible enough to be incorporated into a deep space probe without much modification, significantly aiding electric propulsion, McClue said. In addition, killer power is self-regulating, McClue said. If the reactor gets too hot, its Stirling engines draw more heat away from the uranium core, and if the temperature drops too much, the core naturally contracts, trapping more neutrons and causing more atom-splitting collisions. Incidentally, a quartet of operational reactors could give a Mars outpost a real vacation feel. These devices will need to dump a lot of extra heat into the red planet air. A conversion efficiency of 30% means 70% of the fission heat remains, after all, so they'll come equipped with radiators. A prominent design envisions wide, circular radiators at the reactor's tops, giving them a beach umbrella look. The Killer Power team began investigating possible demonstration missions shortly after Krusty wrapped up, McClue said. The first thing that was thrown at us was a potential moon lander, so we did look at what a potential moon system would be, he said. That concept mission probably won't end up flying, McClue added. It targeted the lunar North Pole, whereas NASA's attention for crewed exploration is now focused on the moon's South Pole. The agency aims to land astronauts in the South Polar region by 2024, as part of the Artemis program, but the team would welcome a space mission if NASA does indeed set one in motion, McClue said. We're excited, he said. We're looking forward to maybe doing something new. Past this, Killer Power is the first truly novel fission reactor concept developed in the United States in the last 40 years, he added. Getting it to space would certainly be a milestone, but the project wouldn't be blazing entirely new ground. Fission reactors have left Earth, after all. The US has launched one reactor to orbit, aboard the experimental satellite SNAP-10A in April 1965. The failure of an electrical component shut that reactor down after just 43 days, and the Soviet Union launched more than 30 fission reactors aboard satellites from 1967 through the late 1980s.